Hello everyone and welcome to today's presentation. I'm excited to have you here. The title of our talk is Understanding Inheritance in Kotlin, and we'll explore how inheritance works, how to declare it, and why it's important for writing better code. Over the next few slides, we'll cover the basics of inheritance, how to enable it in Kotlin, and see some practical examples. So let's get started and dive into what inheritance really is, and how it can help us write more flexible and maintainable programs. So let's dive into what inline functions are. An inline function is a special kind of function where, instead of performing a traditional call, the compiler actually inserts the body of the function directly at the call site. This means there's no overhead from calling the function. The code just gets copied right where it's needed. This optimization can make your program run faster, especially when you're working with higher-order functions or lambdas, because it eliminates the extra call overhead. To declare an inline function, you simply use the inline keyword before the function definition. For example, if you write inline fun add, the compiler knows to insert the body of add directly wherever you call it. So when you call add 3, 4, instead of going through a normal function call, the compiler replaces that line with 3 plus 4 directly. Now, what are the key benefits here? Well, the main advantage is that it eliminates the function call overhead, which can be significant in performance-critical code. This is especially true when working with lambdas, because inline functions help avoid the overhead associated with passing functions as parameters. However, it's important to be aware of some trade-offs. While inline functions can boost performance, they can also increase the size of your bytecode because the function body gets copied to each call site. So, it's best to use them judiciously, especially for small, frequently called functions, to get the best balance between speed and code size. Overall, inline functions are a powerful tool for optimization, but like all tools, they should be used thoughtfully to make your code both efficient and maintainable. A tail recursive function is a special kind of function where the recursive call happens at the very end of the function. This might seem like a small detail, but it actually makes a big difference. Because the recursive call is the last thing the function does, Kotlin can optimize it more effectively. When you add the tailrec modifier to a function, the Kotlin compiler has the ability to transform the recursion into a more efficient iterative loop behind the scenes. For example, consider this factorial function. With the tailrec modifier, Kotlin can turn this into a loop, which helps us avoid building up a large stack of function calls. This is especially important when dealing with large inputs or many recursive calls, because it prevents stack overflow errors. So, understanding tail recursion and how Kotlin handles it is key to writing efficient, safe recursive functions that scale well. So let's talk about object expression in Kotlin. Essentially, an object expression allows us to create an anonymous object on the fly, similar to how Java uses anonymous inner classes. It's a quick way to implement interfaces or abstract classes without having to define a separate named class. For example, imagine you have a button and you want to set a click listener. Instead of creating a whole new class, you can directly create an object that implements the interface right where you need it. It looks like this: button set on click listener, and then you pass in object. Inside, you override the onClick method to define what happens when the button is clicked, in this case, printing clicked. What's really nice about Kotlin here is that the syntax is very concise. We don't need to define a class name, just create the object directly. This approach is especially useful for one-off uses, where creating a full class might feel unnecessary. Overall, object expressions help keep our code clean and focused, especially when dealing with simple, single-use implementations. It's a powerful feature that aligns with Kotlin's goal of making code more expressive and less verbose. Let's take a look at some common collection operations in Kotlin. Kotlin's collections come with a variety of built-in higher-order functions, which are incredibly powerful. For example, if we have a list of numbers like this, we can easily filter out the even numbers using the filter function. Notice how it takes a lambda expression, and in this case, it checks if each number is divisible by 2. The result is a new list containing only the even numbers, which is very handy. We can also transform our list by doubling each number using the map function. Again, we pass a lambda that multiplies each element by 2, and we get a new list with the doubled values. Another useful function is any, which checks if any element in the list satisfies a condition. Here, we're checking if any number is 0, and in this case, it returns false. Finally, we have the sum function, which simply adds up all the elements in the list. What makes these functional operations so valuable is that they make our code more expressive and concise. Instead of writing manual loops, we can perform complex collection manipulations in just a few lines, making our code cleaner and easier to understand. These features really highlight the power and elegance of Kotlin's collection handling capabilities, which align perfectly with our goal of writing more efficient and readable code. All right, let's talk about the difference between equals and equals in Kotlin. When you see equals, think of it as a way to compare the asterisk values of two objects, not their actual memory locations. It's a handy shorthand for calling the equals method, but it also safely handles nulls. So when you write a equals b, Kotlin actually compiles that to a equals b equals null. This means if O is not null, it calls a equals b. And if O is null, it checks if B is also null. Now, on the other hand, the equals operator is different. It checks whether two variables refer to the same asterisk object in memory. So, if you want to know if two variables are pointing to the exact same instance, you'd use equals. To connect this to the overall theme, think about scenarios where value comparison is important versus cases where identity matters. Usually, for comparing content, like strings or numbers, you'll use equals. But if you're working with objects where you need to confirm they are the same instance, then equals is your go-to. Understanding this distinction is key for writing clear, correct Kotlin code. So let's talk about what type inference means in Kotlin functions. Kotlin has this really handy feature where it can figure out the return type of a function if you don't specify it explicitly. This makes your code cleaner and less cluttered. However, there's an exception when it comes to public functions. You do need to specify the return type there. For lambdas or local functions, Kotlin is usually smart enough to determine the return type on its own, so you can often omit it entirely. For example, if I write fun_greet equals hello, Kotlin infers that the return type is string based on the expression. Similarly, fun add a int b int equals a plus b, and Kotlin infers that the return type is int. This feature really helps keep our code concise and readable, which is especially useful when working on larger projects or complex functions. And of course, it ties into our overall theme of writing efficient, clean, and expressive Kotlin code. So how do you define a function in Kotlin? Well, it all starts with the syntax. You use the fun keyword, followed by the name of your function, then parentheses for the arguments, each with their specified type. After that, you specify the return type with a colon, and then the function body inside curly braces. Inside the body, you include your code, and optionally a return statement if needed. For example, if I want to create a simple greeting function, I'd write fun_greet, pass in a name as a string, and then inside the body, print a personalized greeting like println, hello, name. It's also interesting to note that functions in Kotlin can be expressions, which means you can assign them directly using the equals sign. This allows for more concise code in many cases. Another key point is that Kotlin supports top-level functions, so you don't need to place your functions inside a class, unlike Java, where static keywords are required. This makes Kotlin more flexible and easy to work with, especially for small utility functions or scripts. Overall, understanding how to define functions properly helps you write cleaner, more organized Kotlin code, fitting seamlessly into the broader theme of making your programming more efficient and expressive. So let's talk about secondary constructors and init blocks in Kotlin. A class in Kotlin can have one primary constructor, which is declared right in the class header, and then it can also have 0 or more secondary constructors, which are defined inside the class body. Now, whenever you create an instance of this class, the init block runs automatically after the primary constructor. For example, imagine a user class with a primary constructor that takes a name. Inside the class, you can include an init block that prints a message whenever a user is created. You can also add secondary constructors, like one that takes both a name and an age, and in this case, it delegates to the primary constructor using this name. The key thing to remember is that secondary constructors always delegate to the primary constructor, ensuring consistent initialization. The init block is especially useful for any initialization logic that can't be easily expressed with property initializers. Overall, understanding these constructors and init blocks helps you write clearer, more flexible class initializations, which is a core part of mastering Kotlin's approach to object-oriented programming. Thank you for watching, and namaste. I hope this presentation gave you some valuable insights into Kotlin. Remember, exploring new programming languages like Kotlin can open up many opportunities and enhance your coding skills. Keep experimenting, stay curious, and most importantly, have fun coding. Wishing you all the best on your development journey.